Hello, everyone. I'm Alfredo Contreras, Senior Software Architect at Bentley Systems, with 30 years of experience delivering commercial and custom software development solutions to the utilities industry. Thomas Durr is a global electric utilities industry veteran at Siemens with over 30 years experience delivering business solutions with PSS SINCAL and digital twins for distribution system operators. By now, you've probably heard that distribution energy resources have changed the way electric utilities model the grid. What it means is that power grid requires more power flow studies, better data, and at a faster pace. During this presentation, we are going to discuss challenges around digitalization, network model management, and data integration across organizational silos. And we are going to discuss how to overcome the challenges of thinking big about digitalizing design, planning, and operational workflows, how to prove small by breaking down data silos and scoring your data, and how to scale fast by enabling digital workflows with minimal risk. By the end of the presentation, I'm confident you will learn, discover, and understand how to break down data silos between organizations with the digital twin. You'll learn how to enable distribution grid model management with the digital twin and how to digitalize your workflows with the digital twin. In this section, we'll talk in general about developing a digital twin. Obviously, your mileage may vary. To gain real insight and evaluation of your environment will be necessary. Let's get started. Thomas, can you discuss thinking big?
Yeah, thanks, Alf, for handing over to me. Thinking big means for me, first of all, we need to think about what is the current process within our customer. You see here a picture with some steps they normally do perform when they are trying to bring GIS data into the system to do a load flow analysis. You see on the first picture, there is a typical GIS system. They normally go to this GIS system, take a hard copy from this GIS system, and then they are creating a background image from this hard copy within our grid simulation tool, SINCAL. And then the painful work starts. They need to create every cable from the scratch, means manually enter start and end point of this cable. And of course, they also need to have some asset information databases where they can check what cable type and what assets are being included in this specific area. Of course, this also means they are doing everything for this single connectivity study, for this load flow analysis from the scratch and only once. Means if they do it for the next time, they have to renew everything. And when we think about those things, we also need to accept a GIS import is a very valuable stuff. But honestly, we also see, which is shown here on this slide, we do face some challenges. Challenge number one is data veracity. That means GIS data is not suitable for electrical analysis because content and data model from sources are inconsistent, means a single line or cable is not a single cable. It might be two because somebody hasn't drawn this line consistently. The next thing is, challenge number two is data velocity. Means that data changes very quickly. Engineers spend a lot of time in bringing all the data together. And of course, the biggest challenge number three, is that almost 40% of engineering effort spent on vetting and data manipulation means overall more than 20 to 30% of OPEX are related to challenges within challenge number 1 and 2. And there are further challenges like data variety, data volume, data visibility, and of course, data visualization. And now we have been just talking about one single item database system we want to integrate. And when we typically talk to our customers after they have successfully implemented a GIS integration. They will ask us for additional systems like these advanced distribution systems, RDMS. They ask for decentral energy resources management systems and so on. Means we immediately need to consider that a grid model management might help you to get a nice and stable network model management of all the different assets or systems you need to connect. This will help you to further do studies like DER optioneering, EV stress test in a better, more quality-driven way. And maybe if you even would like to add artificial intelligence, machine learning algorithms, this might even be more successful for your solution to get a much better and faster connectivity request study. Thinking about this, Al, maybe this was just an experience from our customer meetings. Do you have a more broader story which shows the overall vision of our customers?
Sure, Thomas. I mean, I think we all understand that utilities are complex organizations composed of many departments and often have many operating units and a network of third-party service providers, all working in concert to serve the electric utility customer. Anyways, they're all working to keep the lights on both inexpensively and reliably. But toward that end, utilities have deployed complex systems to help automate and semi-automate operational processes and workflows. And these systems are integrated with planning and design through either intricate custom integrations or through loosely through data file imports and exports. Now, here's how the digital twin changes the landscape. It's that it essentially, it's one source for all your needs across operations, planning, and design. What's more, you don't have to change your processes and workflows. You change what you want, when you want, and you can leverage your existing IT infrastructure. So, Thomas, I think you really made a good point overall. This is a really great story, and I think this was the vision our company shared when we first met. And here's many of the data sources, for example, that you can enable through a digital twin. Now, as I said, we had a great vision, and so Bentley Systems and Siemens have partnered to offer best-in-class solutions with the digital twin by combining Siemens' flexible planning suite for electrical and pipe networks. That is essentially PSS SINCAL, with Bentley's OpenUtilities and open common data environment to provide an enlightening electrical digital twin solution for grid modernization. Electric utility planning now allows for better insight and decision support from digital network models to ensure the power grid is consistently resilient and reliable. It integrates design and planning workflows for both transmission and design and distributed energy resources planning with on-time, on-demand managed network models and network simulations to make up a grid edge solution that is truly resilient. The Siemens Bentley solution is built around a digital twin to share and update all your data to reduce redundancies and inaccuracies over time. First, it offers rapid creation of network planning models with GIS and other data. Second, it manages updates to your network planning models, therefore improving the network planning process with continuously updated network models. Third, data is accessed as a centralized data source. However, the data is both distributed and federated. And finally, this electrical digital twin integrates a network calculation engine to assist in data validation and in simulations in the cloud. So what do we mean when we say prove small? Well, you can prove small by first compiling a digital twin from your current data, your as-built data, for example. You should typically start with just GIS data and only relevant additional data sources. You prove small by scoring the data relative to the most important use cases or those that you wish to support. The data should be composed of this type of data and therefore score the data based on your highest priority use cases, based on spatial areas that are also of your highest priority. The resulting scorecard should be meaningful, flexible, scalable, and represent a data score over time for the intended use case. By understanding where data is good, you can begin to deploy digital workflows. Where it's bad, you can begin to correct and enrich the data. But when you create a digital twin, how do you manage it? The digital twin should have a process to gather information from a variety of systems, including GIS, asset management, historians, customer information systems, meter data, and so on. The OpenUtilities solution can leverage the AssetWise enterprise interoperability services to federate the data and bridge it into iModel Hub, where data quality services evaluate the data using rule sets, machine learning, and optionally power flow and structural validations. OpenUtilities data quality services measures data and assists in making it good enough to be for the configured use cases to make it complete, unique, accurate, timely, and consistent.
Thanks, Alfredo, for these insights regarding data cleansing and optimization. In the next section, I will focus a little bit more on the challenges we see for an electrical digital grid planner and also give you some insights what a wider Siemens Bentley story could look like. So let me first maybe give some words about our product called PSS SINCAL, which is a very experienced grid simulation software. We do offer this now more than 20 years. We have more than 900 customers and we are in more than 90 countries. It covers electrical grids, but also pipe networks. So you can do the planning on a long-term planning typically, but we also offer very specific modules for protection and harmonics. A current trend commonly is that we see a trend from long-term planning towards a shorter period, which we call operational planning. And here's why we also see integration to other systems is very, very important. I brought with me two nice modules which will help you to manage all these additional renewables. On the left-hand side, you see our module called Hosting Capacity Analysis. Here you do the power flow analysis for a specific grid, checking how much additional DRs or EVs can be added to each grid connection point. The color shown here indicates how much additional capacity you have at this specific grid connection point. You guys can either show it on a more nodal base or with a GIS view. So this helps you to tell your customers, maybe even on a web page upfront, how much additionally rooftop solars, how much EV charger capacity is allowed at this specific point within the electrical grid. So that's a help for your customers on a daily basis. On the right-hand side, you see our module Network Stress Test. This is more a strategic module which helps you to plan for yourself the increase of renewables, which means electric cars or PVs. So you can define on the first side, which is shown on the picture here below, on the screenshot here below, the different groups you want to consider: households, offices, shopping malls, whatever. And then here in the bottom, you can define for these specific years you want to consider how much increase you do expect for additional rooftop solar, for additional EV chargers. And based on this, this program will do a stochastical assessment of the various grid areas cables, whatever, and place either on the left-hand side, on the right-hand side, wherever, the different additional elements. And due to this, will give you a hint which of your assets might come under stress or maybe even exceed the limits allowed. So this helps you to identify where to put some activities regarding maintenance or replacement of the various assets in the grid. So this helps you to focus your maintenance costs on what is really needed. So that's our two modules. I will give you even a wider picture on this. Here you see the capability of SINCAL in a small grid having lots of renewables. And here you first of all define some load profiles for the PV. You define a load profile for the electric car being charged at a certain time, or you define a load profile for a consumer at this point in time. Based on this, you do a complete study of the grid, and you see immediately during night when there's no PV, there is no stress, so there are no problems. During the day, during lunchtime, you see immediately here at the lower right corner, you have a problem with an overvoltage due to the PV in feed. On the other side, more in this area, you see that there is an overcurrent problem because of too much infeed from the renewables. A typical behavior would be from a customer, hey, add simply a second cable here just to avoid this overcurrent problems with the cable. But this is costly. And if you consider that most of the people who want to get rid of the grid, it's maybe not the best idea to place copper into the earth. So what is our solution? We normally say, hey, there might be a shopping mall, a microgrid offering certain flexibilities to this grid. And we can simulate the grid, just this microgrid, just to help the grid during noon. Here you see we will load now the battery from the grid because we want to help the grid to avoid grid congestions. Of course, we have had to unload, first of all, the battery to manage this. So this shows you with an integrated story that you can already plan a grid in a way where you do consider how parallel loads can be avoided, and you can simply avoid costly grid extension costs by using some flexibilities within a grid. And this is our vision. This is where we believe we from Siemens should offer a wider system, which means beside the basic modules we currently have integrated with the Bentley colleagues, we need to show some values, especially towards renewables, for our customers, the utilities. And in orange here, you see displayed all the modules we have in our roadmap where we want to add additional functionalities in an integrated story. But this is not the end right now. We do have many, many more modules. For instance, in the pink area, you see all our protection stuff. At the bottom, you see all the harmonics. So there are a lot of more modules available, which we could bring into our story. Al, is there anything we can get more concrete from you regarding what we currently do, what is on our roadmap?
Sure, Thomas. As previously mentioned, Bentley and Siemens joined forces to meet the challenges facing electric utilities in the new world of smart grids and renewables. As such, we started with our core technologies. Siemens brings the PSS SINCAL analysis engine that can model and simulate the grid from the meter through the substation and into transmission for a true integrated T&D analysis solution. Bentley brings its experience designing and modeling complex infrastructure networks for power, gas, water, communications, roads, and so forth, as well as our experience with asset information management and asset performance workflows. Today, we have 3 product offerings to help you plan, design, and operate the grid, and more to come in 2021. These products are for engineers, designers, planners, and operators to streamline and automate workflows and processes. Today, we have integrated GIS network models and other data sources into a digital twin. We have a workflow manager for planning, engineering, and design processes to support company standards and workflows. We support materials and labor cost estimation. We integrate power flow, short circuit, and interconnection evaluation into both desktop and cloud offerings. And soon you will see a system-wide hosted capacity based on the digital twin, as well as system-wide electric vehicle stress testing and system-wide power storage locating to facilitate non-wires alternative solutions. Here is here you can see a video of automating the evaluation of a distributed energy resources interconnection request. The evaluation can be fully automated or semi-automated with a user that is not an engineer. The process performs a pre-screening process, and if it fails the pre-screening, an interconnection evaluation based on the simulation of the physics of the integration can also be performed. Thomas, can you tell the audience about a real-world customer experience? Hello?
Sorry, Al, I was on mute. Thanks, Al. It's a pleasure to talk about a very nice customer called Schwäbisch Hall in Germany. It's a small city in the south of Germany, but has a great vision and is very, very innovative. They do offer also additional to various multiple other utilities, their grid services, which means they are much bigger than just a small city here. In 2019, we signed the contract, and we established our OpenUtilities module together with the PSS SINCAL, and demonstrated how we can help them to allow them easier and faster grid connection request studies. One of the experience we have made there was that a lot of data import is a little bit problematic from the GIS system. We had problems regarding the relationship between objects. We had problems regarding graphical connectivities. As I mentioned earlier, cables are not just one cable, they are two lines, so we needed to bring them together. Of course, some attributes of the cables have been wrong, and of course, the GIS data sometimes was missing, so we had also problems with wrong addresses. So all these things we need to clean up, and we found nice and beneficial ways to update this, and also we managed to update or actualize the status of the switching positions. So we could demonstrate on this customer how we can help them due to an integrated story with some data cleansing at the beginning, that this makes an utility much faster, much better, and will help them to manage even in the future increased number of connectivity requests to stay in line with their KPIs. El, up to you.
Thanks, Thomas. First, let's talk about the final close up with the key takeaways about what we've just talked about. First, the first takeaway, I think, is that the solution to overcoming data challenges and obstacles of thinking big is the electrical digital twin. It's the digital thread that weaves the modern utility systems together, and it's a single source of truth. But it's not a single database. It's distributed, federated, and vendor neutral. The second key takeaway is to think big, prove small, and scale fast. This recipe will allow you to have better outcomes by increasing productivity, improve decision-making, increase resilience and reliability, which result in increased customer satisfaction. KPIs and digital workflows allow you to measure your outcomes and to streamline operational processes. The overall value is that you work smarter and not harder. The greater the volume of work, the greater the volume of distributed energy resources and distributed energy resource penetration, the greater the value that we can deliver to your digital twin. One final note, think big, prove small, and scale fast should have clear, achievable goals and milestones to minimize risk. With this recipe, you can scale from 0 to advanced digital workflows in about 12 months. Think big by defining your goals, prove small by deploying an as-is digital twin and scoring the data, and begin to scale fast where data is good enough, while you correct and enrich data where it's not.